In this clip, we'll look at the example of how to use differentials to approximate the change in the volume of a cylinder based on changes in its radius and height. So the volume of a cylinder is given as a function of radius and height as we have pi r squared for the bottom area times height. So that'll give us the volume. So if you want to look at the change in volume, the increment in the volume, this will be approximated by the differential for the volume, which is going to be the partial derivative with respect to r. So dv dr times the change in r plus the partial derivative with respect to h times the change in h. And so let's see, so this is then going to be, so if we do the partial derivative of v with respect to r, now we're differentiating this formula here with respect to r. So it's going to be 2 pi r h times dr. Well, I'm going to change the delta r to dr. I think I like that notation better. Means the same thing, it's just a different notation for it. Okay, and then plus, and then we have the partial of the purple guy with respect to h. So pi r squared times dh. Okay, so this is the differential for the volume. Okay, and so now if we look at, say, say we've got a can, like a pop can or something like that, with a radius of 1 and a height of 5 inches, something like this, then at this point the differential would be 10 pi times dr plus pi times dh. All right, so if I factor out the pi, then that's 10 dr plus dh. Now the interpretation of this is that if we change dr by something like epsilon or something, then the volume changes by 10 epsilon. If we change dh by epsilon, then the volume changes by 1 epsilon. So the implication here is that volume is 10 times more sensitive to changes in the radius. So, in other words, if the radius say shrinks by some small amount, like 0.1 inches or something like that, then in order to keep the volume the same, height must increase by 10 epsilon. And so this actually has ramifications for marketing, right? So if you have like a can of Red Bull and it's tall and skinny, they do that to make it look like it's got a lot in there, so that it looks like it's comparable to, say, a regular pop can or soda can, which is maybe something like this size. But actually, because of how sensitive the volume is to the change in the radial dimension right here. If you were going to compare it to a can of soda, it would probably only be something that's about this tall, because if this changes by epsilon, then this is going to change by 10 epsilon in order for things to keep the same. So you'd have this little, for the volume to stay the same. So you'd have this little shriveled up and pathetic looking can. Anyway, so yeah, that's how marketers use calculus to make you think you're getting a better deal than you are.